Question 1. In the context of Oracle Grid Infrastructure, Ista Patel is tasked with configuring voting disks for a 4-node cluster. He wants to ensure high availability while minimizing network traffic during node membership changes. Which strategy should Ista Patel implement for the voting disk placement and configuration? A. Place all voting disks on a single ASM disk group with normal redundancy to simplify management. B. Distribute voting disks across multiple ASM disk groups and configure failure groups to span separate hardware components. C. Use external redundancy for voting disks and place them on local node storage to optimize performance. D. Configure voting disks as file system files on shared NFS storage to leverage net storage flexibility. Answer. Correct answer. B. Explanation. Distributing voting disks across multiple ASM disk groups with failure groups spanning separate hardware ensures resilience against single hardware failures and minimizes quorum loss risk. ASM's failure groups allow voting disks to be placed on independent failure domains, improving fault tolerance. Placing all voting disks on one disk group or single storage device introduces single point of failure, reducing availability. External redundancy relies on underlying storage and may not be cluster-aware, risking data loss or split brain. Using NFS for voting disks is not recommended because voting disks require reliable, low-latency storage to maintain cluster integrity, and NFS can introduce latency and potential data corruption. Question 2. Given the circumstances that an ASM disk in a disk group failed unexpectedly, Wang needs to minimize the performance impact while ASM automatically rebalances the disk group. Which of the following tuning considerations should she prioritize to achieve this? A. Increase the rebalance power to the maximum value to complete rebalancing quickly. B. Lower the rebalance power to minimize EO interference with database operations during peak hours. C. Disable rebalance operations temporarily and rely on manual interventions later. D. Remove failure groups before rebalancing to prevent further disk failures. Answer. Correct answer. D. Explanation. Removing failure groups that contain failed disks prevents ASM from attempting to rebalance onto problematic hardware, which could worsen issues. ASM rebalancing power should be tuned depending on workload. Increasing it to max can cause significant EO contention, while lowering it during peak times is a best practice to avoid affecting database performance. Disabling rebalance operations altogether can lead to long periods of degraded redundancy and risk of data loss. Removal of failure groups is a proactive step to exclude failed components from storage pool calculations. Rebalancing tasks, maintaining cluster storage health. Question 3. While examining the Oracle RAC architecture, Ista Singh observes frequent global cache wait events impacting query performance. What is the most appropriate approach to mitigate these global cache bottlenecks without compromising RAC availability? A. Increase the size of the redo log buffer to reduce redo generation. B. Tune the interconnect network to lower latency and higher throughput for faster cache fusion communication. C. Reduce the number of RAC instances to decrease cache coherency overhead. D. Enable flashback data archive to decrease undue space consumption. Answer. Correct answer. D. Explanation. Enabling flashback data archive primarily helps manage undue space and data retention, but it does not mitigate global cache wait events or interconnect latency issues. Increasing redo log buffer size affects redo generation, not cache fusion. Reducing RAC instances decreases parallelism and scalability, but is a drastic step that impacts availability and throughput. The best approach to reduce global wait events involves optimizing the interconnect. The private high-speed network responsible for cache fusion. Well-configured interconnect reduces latency and speeds communication, minimizing cache contention while preserving the RAC benefits of scalability and high availability. Question 4. Considering the evidence from recent clusterware performance reports, Lopez is evaluating the use of grid plug and pay GPMP in a large cluster deployment. What key advantage did GPMP provide over manual configuration that justifies its adoption? A. GPMP automatically tunes ASM disk group attributes based on workload patterns. B. GPMP enables automatic discovery and configuration of network and storage resources, reducing human errors. So DPMP manages cluster node membership and voting disk placement dynamically at runtime. eDPNP replaces the need for Oracle cluster registry backups by maintaining real-time configuration snapshots. Answer. Correct answer. A. Explanation GPNP primarily automates the discovery and configuration of network and storage resources in the cluster, thus reducing manual errors and administrative overhead. It does not automatically tune ASM disk group attributes based on workload patterns. The tuning remains a DATAC. GPNP does not manage voting disk placement or cluster membership dynamically at runtime. These are managed by clusterware components. An administrative policies. GPNP does not replace Oracle cluster registry backups but facilitates easier configuration management. The automation of network and storage resource setup reduces complexity, accelerates deployment, and improves cluster stability. Question 5. Mr. Ahmed is performing rolling patching on a 3-node grid infrastructure cluster to avoid downtime. During the process, one node fails to rejoin the cluster after patching. What is the best course of action to resolve this situation while minimizing impact on the cluster? A. Remove the failed node from the cluster permanently and rebuild it from scratch. B. Use the cluster verification utility (CVU) to identify configuration issues, then reattempt node addition after resolution. C. Immediately roll back the patch on all nodes to restore cluster functionality. D. Force a cluster restart to allow all nodes to synchronize their patched state. Answer. Correct answer. C. Explanation. Rolling patching is designed to minimize downtime, but if a node cannot rejoin post-patch, rolling back the patch across all nodes preserves cluster integrity and availability. Removing a node permanently is drastic and may cause service disruption. Using CVU is appropriate for diagnostics but does not directly resolve the patch failure without corrective action. Forcing a cluster restart is risk is downtime, defeating the purpose of rolling patching. Rolling back ensures that all nodes are in a consistent state, allowing further troubleshooting or patch retries with minimal impact on availability. Question 6. Within the framework of ASM administration, Chen wants to migrate an existing database's storage from traditional file system to ASM with zero downtime. Which strategy best aligns with Oracle's recommended approach for ASM migration in production environment? A. Use RMAN to perform full backup and restore the database files directly onto ASM disk groups. B. Shut down the database, move data files manually to ASM storage, then restart the database. C. Utilize the ASM file transfer utility, ASRU, to copy files while the database remains online. D. Use RMAN's convert command with the database online, combined with altering file names to point to ASM. Answer. Correct answer. B. Explanation. The recommended method for ASM migration involves shutting down the database to move files safely, then restarting the database to avoid data corruption. RMAN backups and restores are often used but require downtime and are more time-consuming. ASM file transfer utility, ASRU, is used primarily for disk failure recovery, not migration. RMAN's convert command supports offline conversions but does not inherently support zero downtime. Manual file moves with database offline ensures consistent file state and successful migration to ASM storage, minimizing risks of data inconsistency. Question 7. Taking into account Oracle RAC service management features, Garcia wants to ensure continuous workload balancing and failover for an application using multiple RAC instances. Which service configuration is most effective for this purpose? A. Create single service associated with all instances and configure it with preferred and available instance lists for failover. B. Create multiple services per instance with exclusive affinity to each instance to isolate workloads. C. Configure services only on the primary node and rely on application retry logic for failover. D. Use client-side load balancing exclusively and disable server-side load balancing to simplify configuration. Answer. Correct answer. A. Explanation. Creating a single service associated with all RAC instances and defining preferred and available instances allows Oracle to balance workload dynamically and provide automatic failover within the cluster. Multiple services with exclusive affinity limit flexibility and scalability, relying on application retry logic, is less robust and causes potential downtime. Disabling server-side load balancing removes an important layer of automatic distribution, reducing cluster efficiency. Proper service configuration leverages Oracle's RAC workload management capabilities, ensuring high availability and scalability with minimal manual intervention. Question 8. In terms of Oracle Local Registry OLA functionality, is Evans needs to explain its role in cluster node operations to a junior DBA. Which statement most accurately describes the importance of OLA in the cluster architecture? A. OLA stores cluster configuration backup centrally for all nodes. B. OLA keeps local node-specific cluster resource information used during node startup. C. OLA manages network configuration dynamically for the cluster interconnect. D. OLA is the repository for ASM disk group metadata across all nodes. Answer. Correct answer. C. Explanation. The Oracle Local Registry primarily contains local node-specific cluster configuration data needed during startup and recovery, including node-specific resources. It does not centrally store backups. That is the OSICA's function. OLA is not responsible for managing network configuration dynamically. The network settings are managed by clusterware ADP. ASM disk group metadata is managed by ASM itself, not the OLA. The OLA's primary role is to maintain local state and resource information to assist in node-specific clusterware operations. Question 9. For many years, the use of Flex ASM architecture has been promoted for improving ASM instance availability and flexibility. Mr. Kim wants to understand the core architectural difference between traditional ASM and Flex ASM. Which statement best explains this difference? A. Flex ASM consolidates ASM instances to a single node for centralized management. B. Flex ASM allows ASM instances to run on a subset of nodes, decoupling ASM availability from database instances. C. Flex ASM replaces ASM disk groups with file systems for greater storage flexibility. D. Flex ASM enables ASM to run in a containerized environment for cloud deployments only. Answer. Correct answer. B. Explanation. Flex ASM architecture enables ASM instances to run on a limited number of nodes, allowing database instances on all nodes to connect to remote ASM instances, enhancing flexibility and availability. This decouples ASM availability from database node availability and facilitates rolling maintenance. It does not consolidate ASM instances to a single node, which would be a single point of failure. ASM does not replace ASM disk groups with file systems. ASM storage management remains consistent. Flex ASM is not exclusive to containerized or cloud environments. It applies broadly to RAC environments to improve manageability. Question 10. Upon closer examination of cluster security best practices, Johnson is implementing secure cluster communication using Oracle wallets. What is the primary benefit of using Oracle wallets in this context? A. Wallets store user credentials for database login authentication. B. Wallets provide encrypted storage for private keys enabling secure inter-node communication. C. Wallets maintain cluster node IP addresses to ensure correct network routing. D. Wallets automatically patch clusterware components during security updates. Answer. Correct answer. C. Explanation. Oracle wallets in cluster security primarily store and protect private keys and certificates necessary for securing inter-node communication, ensuring encrypted and authenticated message exchange between nodes. Wallets do not store user credentials for database login. Those are managed by other authentication mechanisms. Wallets do not manage IP addresses or network routing. Network configuration managed by clusterware and OR-level tools. Patching clusterware components is unrelated to wallets. Proper use of wallets strengthens cluster security by preventing unauthorized node communication and mitigating risks of eavesdropping or tampering. Question 11. Under the assumption that Mr. Thompson is managing a RAC cluster with high EO workload and wants to ensure optimal interconnect performance, he observes high latency on the private interconnect network. What is the most effective way to improve the interconnect performance without major hardware upgrades? A. Increase the size of the interconnect buffers and tune the MTU, maximum transmission unit size for jumbo frames. B. Add more voting disks to distribute interconnect traffic evenly across nodes. C. Reduce the number of RAC instances to decrease network contention. D. Disable Oracle net compression on interconnect traffic to minimize CPU-age. Answer. Correct answer. A. Explanation. Tuning interconnect buffers and enabling jumbo frames. Larger MTU reduces packet fragmentation and improves throughput and latency on the private interconnect. This tuning approach leverages existing hardware more efficiently. Adding more voting disks does not affect interconnect latency but quorum management. Reducing RAC instances negatively impacts scalability and availability. Oracle net compression is usually not applied to the private interconnect, and disabling it would not necessarily improve latency but might reduce CPU overhead. The key factor remains network tuning. Proper interconnect optimization ensures better cache fusion performance and cluster responsiveness. Question 12. Based on the information about ASM disk group redundancy, Nguyen has created an ASM disk group with external redundancy for critical database files. She is concerned about data protection in this setup. Which of the following best explains the implications of external redundancy in ASM? A. ASM automatically mirrors all data within the disk group to protect against disk failures. B. External redundancy assumes the underlying storage provides data redundancy and ASM does not mirror files. C. ASM uses triple mirroring internally to protect files regardless of redundancy setting. D. External redundancy enables ASM to replicate data across multiple clusters for disaster recovery. Answer. Correct answer. D. Explanation. External redundancy means that ASM assumes the underlying storage layer like SAN or RAID handles redundancy, so ASM does not perform mirroring internally, reducing ASM overhead but increasing risk if storage is not redundant. ASM itself does not do automatic mirroring in this mode. Triple mirroring is only available in high redundancy settings, not external redundancy. ASM does not replicate data across clusters. That is done via data guard or other replication solutions. External redundancy is appropriate when storage level fault tolerance is guaranteed, but DBA must confirm it carefully to avoid data loss. Question 13. Taking into account Mr. Silver's need to diagnose clusterware node membership issues, which Oracle clusterware components should he investigate first to determine the cause of unexpected node evictions? A. Oracle Cluster Registry OSRA to verify cluster configuration consistency. B. Voting disks to check quorum and node membership votes. C. Oracle Local Registry OLA to inspect local node configuration. D. Grid plug and pay GPNP orgs for network auto configuration errors. Answer. Correct answer. B. Explanation. Voting disks are crucial for maintaining cluster quorum and node membership decisions. Node evictions often result from quorum loss or communication failures detected through voting disks. Investigating voting disk health, location, and accessibility is the first step. OSR stores configuration but is not directly involved in membership votes. OLA contains local info and does not decide cluster membership. DPNP deals with network storage auto-configuration. The node evictions due to quorum issues primarily relate to voting disk status. Ensuring voting disks are accessible and healthy is key for cluster stability. Question 14. When considering rack-specific tuning, Rodriguez notices frequent D for busy waits on her rack instances. What is the primary cause of this wait event and what tuning approach should she take? A. High contention on the shared pool and increase the shared pool size. B. Inefficient SUL causing excessive redo log generation and increase redo log size. C. Contention on global cache data blocks. Tune application to reduce cross-instance locking. D. Slow network communication between rack nodes. Replace interconnect hardware. Answer. Correct answer. C. Explanation. The D for busy wait event indicates contention for global cache blocks managed by the Global Cache Server GCS in rack, often caused by multiple instances trying to access and modify the same data blocks simultaneously. The best approach is to tune the application to reduce block contention by minimizing cross-instance transactions or using data partitioning strategies. Increasing shared pool size or log size does not address this issue. Network replacement might help, but is a costly last resort. The main issue is workload contention. Understanding rack cache fusion and avoiding hot blocks is essential for performance. Question 15. Throughout the course of an ASM disk group creation, Mr. Davies must decide on the appropriate failure groups. Which principle should guide him in designing failure groups to maximize availability and data protection? A. Failure groups should group disks physically located on the same hardware component to simplify maintenance. B. Failure groups should be based on disks spread across different power supplies, controllers, and racks. C. Failure groups are only needed when external redundancy is selected for the disk group. D. Failure groups are deprecated in ASM 19 and no longer affect redundancy or rebalancing. Answer. Correct answer. C. Explanation. Failure groups are critical for redundancy settings like normal and high redundancy where ASM mirrors data across failure groups. However, when external redundancy is selected, ASM assumes no mirroring and failure groups have no effect on data protection. Grouping disks on the same hardware creates single points of failure, reducing availability. Failure groups should ideally be spread across independent components to isolate failure domains. Failure groups are still relevant in ASM 19 and integral to redundancy management. They are not deprecated. Question 16. Considering the evidence from recent troubleshooting logs, Becker finds multiple OCR corruption errors after a power outage. What is the most effective recovery approach she should follow to restore cluster operation? A. Reinstall grid infrastructure from scratch on all nodes to ensure clean state. B. Restore OCR ROM. A recent backup using OCR-config utility and verify cluster state. C. Rebuild voting disks and OCR simultaneously to ensure quorum and configuration. D. Remove and re-add nodes to the cluster to refresh OCR information. Answer. Correct answer. A. Explanation. The correct answer is to restore OCR. A backup using OCR-config or similar tools. OCR contains critical cluster configuration and should be restored to a consistent state from backups after corruption. Reinstalling grid infrastructure is drastic, time-consuming, and unnecessary if the OCR backup exists. Rebuilding voting disks does not fix OCR option as voting disks manage quorum configuration data. Removing and re-adding nodes does not repair corrupted OCR data. Timely OCR backups and recovery are vital cluster maintenance practices. Question 17. As demonstrated by Mr. O'Connor's RAC deployment, which of the following best describes the purpose of the Global Resource Director GRD in Oracle RAC? A. Tracks the location and ownership of data blocks across all RAC instances. B. Manages network connections between client applications and RAC instances. C. Coordinates ASM disk group metadata updates in clustered environment. D. Provides backup and recovery information for RAC instances. Answer. Correct answer. D. Explanation. The GRD is responsible for tracking global resources like data blocks, ownership, and lock status across RAC instances, enabling cache coherency. It does not manage client connections, which are handled by Oracle Net and Service layers. ASM metadata is managed by ASM itself in GRD. Backup and recovery are managed by RMAN and Oracle database utilities in GRD. Understanding its role in resource locking and synchronization is fundamental to RAC scalability and consistency model. Question 18. The fundamental question is, Mr. Muller wants to implement RAC 1 node to maximize resource usage while maintaining high availability. What key characteristic distinguishes RAC 1 node from traditional RAC configurations? A. RAC 1 node runs single instance that can fail over to other nodes but does not support multiple active instances. B. RAC 1 node requires ASM disk grouped with external redundancy only. C. RAC 1 node automatically performs workload balancing across all nodes at all times. D. RAC 1 node is designed for single node clusters only without failover capability. Answer. Correct answer. C. Explanation. RAC 1 node runs a single active instance at a time but supports dynamic failover to other nodes, providing availability with minimal overhead. It does not run multiple active instances simultaneously like traditional RAC. ASM redundancy type is unrelated to RAC 1 node specifically. Workload balancing is not automatic across all nodes constantly but handled during failover or manual relocation. RAC 1 node requires a multi-node cluster to enable failover and scalability. This configuration is optimal for applications requiring high availability with simpler resource usage. Question 19. When evaluating patching strategies for grid infrastructure, Schultz plans to apply rolling patches. What is the primary advantage of rolling patches in a RAC environment? A. They allow patching to be applied to all nodes simultaneously, reducing total patching time. B. Rolling patches enable patching one node at a time, maintaining cluster availability. C. They require complete cluster shutdown before patching to ensure consistency. D. Rolling patches automatically roll back on patch failure without manual intervention. Answer. Correct answer. A. Explanation. Rolling patches allow patching one node at a time while the rest of the cluster remains operational, minimizing downtime and maintaining service availability. Applying patches simultaneously all nodes at once is contrary to rolling patch philosophy and causes downtime. Complete cluster shutdown is not required for rolling patches and would negate their primary advantage. Automatic rollback is not guaranteed. Patch failure typically requires manual remediation. Rolling patching is best practice for high availability environments like RAC. Question 20. In light of recent developments, Mr. Fernandez is configuring ASM disk rebalancing and wants to avoid excessive EO impact during peak hours. Which ASM dynamic parameter adjustment is best suited to control the rebalance operation intensity? A. Increase ASM power limit to speed up rebalance regardless of workload. B. Set ASM power limit to a lower value during peak hours and higher at off-peak times. C. Disable ASM rebalance entirely to avoid EO overhead. D. Modify ASM disk string to exclude disks during rebalance. Answer. Correct answer. B. Explanation. The ASM power limit parameter controls the speed and intensity of ASM rebalancing by limiting the number of concurrent EO operations. Setting it low during peak hours reduces impact on database EO and increasing it during off-peak times speeds completion. Disabling rebalance can lead to degraded redundancy and risk of data loss. Changing ASM disk string affects which disks ASM uses, but does not rebalance speed. Proper tuning of ASM power limit balances performance and availability. Question 21. From a practical standpoint, Mr. Johnson notices that his ASM instance on one node frequently restarts during peak operations. What is the most probable cause and recommended action to address this? A. ASM instance is overloaded due to excessive rebalance power. Reduce ASM power limit. B. Corrupted ASM disk group metadata restore from the latest backup immediately. C. Network issues causing cluster node disconnections. Verify interconnect stability. D. ASM instance version mismatch across nodes. Perform a rolling upgrade to synchronize versions. Answer. Correct answer. D. Explanation. ASM instance version mismatch across nodes can cause instability and restarts, as inconsistent versions may fail to communicate properly in the cluster environment. Performing a rolling upgrade ensures all nodes run compatible versions, maintaining cluster integrity. Excessive rebalance power affects performance but is unlikely to cause ASM restarts. Metadata corruption typically causes disk group mount failures, not instance restarts. Network issues usually cause node eviction or cluster instability, not ASM-specific restarts. Proper patch and version synchronization is crucial for cluster health. Question 22. Taking into account the evidence from RMAN backups in a RAC environment, is Martinez wants to ensure all archived logs are safely backed up without affecting performance. Which approach aligns best with Oracle RAC backup best practices? A. Backup archived logs from one node only to avoid duplicate backups. B. URMAN backup with the backup archival log or command from all nodes simultaneously. C. URMAN incremental backups exclusively to avoid archival log backup. D. Disable archival log mode during backups to reduce EO. Answer. Correct answer. C. Explanation. RMAN incremental backups can reduce the need for frequent archival log backups by capturing only changed data, thus minimizing EO load. Backing up archived logs from only one node avoids duplication, but might risk missing logs if not coordinated. Backing up from all nodes simultaneously causes redundant backups and increased EO. Disabling archival log mode is not an option in RAC for protection and recovery. A balanced backup strategy combining incremental and archival log backups tailored to workload is recommended for RAC. Question 23. Given the circumstances that Ispatel needs to configure connection load balancing for a RAC database accessed by a global user base, which load balancing method provides the best client-side balancing while minimizing failover delays? A. Use server-side load balancing with connection failover disable. B. Configure client-side load balancing with fan fast application notification enabled. C. Use only VIP addresses with no load balancing enabled. D. Configure client-side load balancing with round-robin DNS exclusively. Answer. Correct answer. B. Explanation. Client-side load balancing with fan enables fast detection of node failures and reroutes connections quickly, minimizing failover delays while distributing load efficiently. Server-side load balancing alone does not affect client connection distribution. VIPs provide node-level failover but do not perform load balancing. Round-robin DNS provides basic load balancing but lacks rapid failure detection and benefits. Combining client-side load balancing with fan is best practice for global RAC deployments to improve availability and responsiveness. Question 24. In what ways can IstaKim optimize ASM disk group performance when adding new disks to an existing disk group without causing significant disruption? A. Add disks with external redundancy and disable rebalance operations temporarily. B. Add disks and immediately increase the ASM rebalance power to speed up data movement. C. Add disks with appropriate failure groups and tune rebalance power to balance speed and system load. D. Remove existing disks before adding new disks to maintain disk group size. Answer. Correct answer. C. Explanation. Adding disks with properly designed failure groups maintains redundancy and fault tolerance. Tuning ASM rebalance power carefully allows a balance between rebalance speed and system load, avoiding performance degradation. Disabling rebalance is not recommended as it causes degraded redundancy. Adding disks with external redundancy without proper failure groups risks data loss. Removing disks before adding new ones unnecessarily reduces storage capacity and availability. Careful planning ensures smooth expansion without major disruption. Question 25. During the process of upgrading Oracle Clusterware, IstaSing wants to minimize downtime and service impact. Which of the following best describes the recommended upgrade approach? A. Perform a full cluster shutdown before applying the patch to ensure consistency. B. Use a roll-in upgrade method, patching nodes one at a time while the cluster remains online. C. Upgrade all nodes in parallel using a script to save time. D. Deconfigure and reconfigure clusterware on each node during the upgrade. Answer. Correct answer. A. Explanation. Performing a full cluster shutdown before patching ensures a clean and consistent upgrade environment but results in downtime, so it's not preferred for high availability. A recommended approach is a roll-in upgrade, patching nodes one by one without shutting down the entire cluster, minimizing service impact. Parallel upgrades can cause inconsistency and cluster instability, deconfiguring and reconfiguring cluster, usually unnecessary and risky during patching. Rolling upgrades are the industry standard for minimizing downtime in RAC environments. Question 26. According to recent studies on RAC backup strategies, which method best ensures minimal data loss and maximum availability during backups? A. Euroman incremental backups with archive log backups and apply logs frequently. B. Perform full database cold backups only during scheduled maintenance windows. C. Disable archive logging during backups to avoid performance degradation. D. Rely on ASM snapshots for backup without using RMAN. Answer. Correct answer. B. Explanation. Cold backups guarantee data consistency but require the database to be offline, causing downtime, which is not ideal for RAC environments requiring high availability. RMAN incremental backups combined with archive log backups and frequent log application minimize data loss and maintain availability. Disabling archive logging removes the ability to recover to point in time and is not acceptable for critical systems. ASM snapshots are useful but not replacements for RMAN backups. The optimal backup strategy balances consistency, recovery time, and availability. Question 27. The primary reason for Ista Rodriguez wanting to monitor the global cache survey GCS is to A. Track the locations of data blocks and resolve cache coherency conflicts among RAC instances. B. Manage Oracle net listener load balancing and failover policies. C. Control ASM disk group membership and rebalance status. D. Handle Oracle cluster registry backups and restore operations. Answer. Correct answer. A. Explanation. GCS manages the ownership and state of data blocks across RAC instances, ensuring cache coherency and synchronization. Monitoring GCS helps identify performance bottlenecks related to cache fusion and block contention. Oracle NetListener is responsible for client connections and load balancing, not GCS. ASM Disk Group Management is separate from GCS, which focuses on RAC instance global cache. Oracle Cluster Registries, a cluster configuration repository unrelated to cache management. GCS monitoring is vital for tuning RAC performance and troubleshooting. Question 20. With respect to cluster verification utility, CVU, what is its primary function when preparing an Oracle RAC environment? A. To validate the readiness of hardware, software, and network components before installation or upgrade. B. To configure ASM disk groups automatically based on hardware detection. C. To perform automatic failover of cluster nodes during node failure. D. To patch grid infrastructure components during rolling upgrades. Answer. Correct answer, D. Explanation. CU's main purpose is to check the cluster environment readiness, including hardware compatibility, software version, and network configuration before installation or upgrade. It does not configure ASM disk groups, manage failover, or apply patches. Rolling upgrades and patching are handled by Oracle's OPATCH utility and grid infrastructure management tools. Running CVU reduces installation errors, validating prerequisites and environment compliance before critical operations. Question 29. During the process of configuring RAC services, Gupta wants to ensure that her service runs only on specific nodes while providing automatic failover. What is the best way to achieve this? A. Configure the service with preferred and available instance lists specifying target nodes. B. Create a service with exclusive affinity to a single node and disable failover. C. Use load balancing advisory to distribute the service across all nodes equally. D. Assign the service only to the node with the highest CPU capacity to optimize performance. Answer. Correct answer, A. Explanation. Assigning preferred and available instance lists allows services to run primarily on designated nodes with automatic failover to available nodes if preferred nodes fail. Exclusive affinity disables failover and reduces availability. Load balancing advisory helps clients choose nodes but does not restrict services to specific nodes. Choosing nodes based only on CPU ignores other factors like workload, availability. Properly configuring service affinity and failover ensures balanced, resilient workload management. Question 30. When analyzing ASM disk group attributes, which factor most significantly affects the rebalance operation duration and system impact? A. The number of ASM instances connected to the disk group. B. The rebalance power setting, which controls parallelism of rebalance EO. C. The ASM instance version running on each node. D. The frequency of Oracle cluster registry backups. Answer. Correct answer, B. Explanation. The rebalance power setting directly controls how many EO requests ASM can perform concurrently during rebalance, significantly impacting rebalance duration and system resource utilization. Increasing rebalance power speeds the operation but can cause higher EO contention. The number of ASM instances does not directly affect rebalance. ASM instance version affects compatibility, not rebalance duration. OSAR ACUP frequency does not influence rebalance operations. Tuning rebalance power is critical for balancing performance and availability during storage changes.